So let's start off talking about song ratings again. I don't have any slides for today. We're going to spend most of the time in IntelliJ. Let's have some fun with song ratings again to start. Finally do have my solution code on the right laptop this time. So let's find out what the top songs are. So as a reminder for this project, we're reviewing song ratings. And for Monday's lecture question, you went to the UB rating songs. It's way too loud. And we can use this to generate data, which we got quite a few songs in here. We can use to generate data for our app to use. So I have here my solution code in one of these, in this one. And in the handout code, there's this song ratings 2021. I mean, it's up to you what you want to do. These files aren't part of your submission. They're not checked by Autolab or anything. So whatever you want to name these, or if you just want to overwrite the 2021, whatever. The kind of standard thing to do is create a new file for 2022. Paste all the songs, the ratings in there. And now we have, as of right now, what the ratings are. And we can find out what the most popular songs are for this class. So in the music.main method, I have a bunch of code that's by default commented out because it'll be errors because these methods don't exist yet. Once you start implementing those methods, I'm going to call this top songs by Bayesian average. Add two ratings of value 3. That's going to give us the Bayesian rating for each song, calling your Bayesian rating method. And then call your top K method based on that function to be able to get the top K songs and then open that playlist using that helper method. So I'm going to call this, we can decrease this to top 10. To get the top 10, I'm going to call that top by Bayesian average and see what the top 10 songs are. I did that way wrong.
That's 2 for 2.
We'll get there. Yeah, one person liked the song, and then 2 people are like, I don't like that song. And then everyone else is like, I don't care enough to vote for that song. It's usually how they get on the bottom.
I actually made the name spell backwards coconut malt.
Oh, is that? I actually had that one highlighted. No, that ain't it. But yeah, that was good. And then there's the your ratings. Oh, this isn't even. Well, there goes my thing. But there's also your ratings. So if you agree or disagree with the top 10, I had this set up and I overwrote the file. Oh well. If you agree or disagree with the top 10, you can put your ratings on there in this file and then call the other main. There's another method in here that will take your ratings into account. This one is going to call the song cost function. So once you have the song cost function ready, and then I take the inverse of that, so the lowest cost song is going to be the top one. And then we can take those into consideration. It's actually a version of that song that's censored enough I could play it in lecture. It's just, I can't believe that song was a thing. So now that we have some ratings, we have some data for this semester. Feel free to use that in your testing. If you grab the data right now, you know what the top 10 is supposed to be. You can use that as a test case to help test your code. But let's talk about some testing. So we talked about some task 1 testing. I'll show you a little bit more of how to test this and kind of remind you of how to test these things. This is my actual test suite from Autolab. So if you are curious what's being tested, like for example, when I say average energy rating is test 1, I have a list of song ratings. This is pretty much exactly what I showed in lecture when I did my sample test case. Get those song ratings, call the average method. I need some more room here. Call your average method, where the function is going to take in a song rating and just read the energy level. With energy level, this is still causing some issues, so hopefully we can squash all these remaining problems for anyone who hasn't gotten the word yet. Song rating, when I first released the assignment, this was called energy. It's now energy level. It's supposed to be energy level. So if you cloned the repo really early and haven't fixed that, haven't updated that, change that to energy level if you're still getting errors in Autolab. And anyone getting errors in Autolab, let me know. There are some common causes for that. I want to look into it to make sure that there's no other issues that I'm not aware of that aren't like misspelling something or something like that. I can help you out with those. Energy level, this was a cause of a lot of them. That should be energy level with a capital L. That'll give you errors in Autolab. So for test 1, I'm grabbing that energy level. There's a function that gets the energy level, computes the average using your method. For this setup, I expect 4.0 based on these averages, 2 3s, 2 5s, normalize out to 4, and then an extra 4 in there. And then we compare those doubles. We never use equal equal. We're just going to call this compare doubles. And I always recommend having that as a separate method so you don't have cut and paste errors. Just call compare doubles, write that method once, and then never write it again. Never worry about epsilon again. Just write it once, and then call it every time you need to compare two doubles. We can call this with other values. Here I'm taking the average length of strings, similar to what we did last Wednesday, where I'm taking different type parameters and doing different things with them. Here I have a bunch of strings. I'm going to average the length of them. Again, just calling your statistics.average method, but now the type parameter is string instead of int. Give it the list of strings and a function that takes a string and returns a double. Here I'm actually returning an int because these aren't really, these test cases weren't prepared for a lecture. These are the ones that are actually running in Autolab. But for a lecture, I would put number.length.toDouble to be very explicit about what this thing is doing. Here I'm just returning an int and then letting Scala figure out that it should be converted to a double. But I would put toDouble if this was, if I was grooming this for a lecture example. And then strings by length, same idea. Oh, this is top K though. Top K, same idea, takes a function, takes a list, but now the top K that should be returned. And these are in decreasing order. So this is the idea is to return like a top 10 list. When we play the songs and I play my top 10 list, I want the first one to be the best song. So when you're returning these, make sure your first one is the highest scoring or the highest value according to that comparator. Make sure the first one is the highest. We've been getting that question on Piazza and office hours a bit, where some of you are returning like this as the third, second, and then first. Make sure first is first. We want the top song to be the first song in the playlist is the idea behind that. So top 10, the very first one should be the top value. And then we leaked one, I don't want to leak every test case. You already have the names of them, so the names are fine. But I want to get to the song cost function. Very slowly. All right. Let's do one that's not Rick Ashley. I use Dua Lipa for too many examples, I guess. But this, for the song cost function, I use the same two songs over and over again. Let's use Kendrick. So for the song cost function, we need a list of songs and also the ratings from a particular user. So I have one song here. I'm creating a song with a list of ratings, so I have some data to work with. And you only need one song, really. And then I have my user ratings, which are going to make sure that this song, this YouTube ID, is rated by the user. For this particular test case, is a test case for the user rating this song with a 5. So I'm going to make sure my map contains that song, rates this song a 5. I'm going to compute by hand the ratings, add in my two ratings of value 3, compute the average to get the Bayesian average, and then go according to my song cost function with a rating of 5, go through the math to get what that song's cost should be with 2 5s, 2 4s, and a user rating of 5. Then what do I expect the cost of that song to be? Oh, I'm thinking incubators where you need a list of songs. We're not doing that part. I expect the cost to be 0.05. So I'm going to get your cost function based on those user ratings. The song cost function, the method named song cost function, is going to take a map of user ratings. Those are your ratings. Like the second example when we added the user ratings file to be able to get a customized top 10. We take those user ratings, that map, in the cost function, and then call the cost function. This method returns a function. We're going to call that function on a song that we want to get the score of. That's going to, or the cost of. That's going to give us the cost, and then we check to see if that cost is what we calculated when we ran through all the numbers. We should get 0.05. If we take 2 5s, 2 4s, and we're adding 2 fake ratings of 3, the average should be 4. And then it's 1 over that times the user rating, so it should be 1 over 20, which would be 0.05, would be how we computed that 0.05. So according to the math spelled out in the document, that's what we would expect to get. All right, any questions on testing objective 1 or task 1? Most of you are past this task already, but any other questions about it or how to test these things? Let's hop over to task 2. Today we want to talk about some task 2 testing. I want to hide that. Compare songs I'm fine with. This isn't what I have in the grader. This is actually a broken method. This isn't what I have in the grader, so don't. Oh, and now everybody's going to copy that too. It's not what I have in the grader, and this is actually wrong because this assumes the order of the ratings to be a very specific order. In the grader, I have to sort the ratings first to make sure I have a deterministic order. Just like when we compared 2 lists before, we needed to sort first. I need to sort here. It's fine for testing my own code where the order is the same every time, but it's not a correct comparison. But anyway, let me hide that so people don't use that one. I thought I did this all before. Ugh. I thought I hit all these already. Like I overwrote it when I overwrote those ratings too. All right, so we have the tests for this one, and I won't do a live coding of a test. I want to do live coding of a recursive method. But I want to give you some guidance on how to test this. Now on task 2, for those of you who haven't seen the document yet, haven't started thinking about task 2, there is no required testing. Autolab will not check your tests. You don't need to submit tests. When you submit, Autolab won't check any of your tests. There are no incorrect and correct solutions in Autolab to run your tests against. None of that happens for task 2. None of that happens for the application objective either. So there are 2 cases where we're backing off with the required testing. So just a heads up on that if you haven't been aware of that. But I do want to still show you how to test these things and how you can set up some of the testing. So first, your ratings file that's given. If we're running this code to parse the user ratings, if we look at the your ratings file, we have these 4 ratings, these 4 songs, and we want to take the YouTube ID and map the YouTube ID to the rating. So I should get Kendrick Lamar's YouTube ID mapped to 5, and so on, mapped to 4, mapped to 5, mapped to 2. I'm not going to read off the YouTube IDs because it's just a random scrambling. But we want to make sure that when we read this file, we're going to get a map that maps those YouTube IDs to their ratings from the file. That's our goal of this one. So each time we process a line, we want to grab the YouTube ID and grab the rating, convert that rating to an integer, and then add that as a key value pair to our map. That's our goal for this objective. So if we call our method on this yourratings.csv, we would expect this map to be returned. So I'm going to call the method on that file. That's going to give us a map of string to int that we computed. We expect it to be the same as this. And we're just going to hit it with the equal equal. With maps, we can usually get away with this. At least in this class, I'm careful to make sure you can get away with this. With maps, you can get away with just doing equal equal. And what that'll do, just a flashback, a reminder, it'll check each map, make sure they're the same length, and then check for each key in each map that each key maps to the same value and that they contain all of the same keys. So we can get away with equal equal here. When it checks the keys and the values, it's going to use equal equal on each of those. So if we had a map of YouTube ID to double, for example, and the ratings were all doubles, we wouldn't be able to use equal equal. We would actually have to go through each map and then compare doubles on each value of the map, which would be a bit more of a pain, a bit more work. So I make sure the values are not doubles in maps, just so your testing isn't as painful, just because that's tedious, and I don't know what you actually learn from that, except that I make you do some extra crap. There's not really much you learn from that. So that's the idea. You call the function with that file name. Oh, I know what I was thinking earlier. With that file name, and then make sure it returns the right map. So with this, just looking at this test case, that should make it clear what your method is supposed to do, just in case it wasn't clear from the wording, what exactly you're going to do. You're going to open that file, read it. Each line, you're going to create a key value pair for that. And you don't have to worry about anything with duplicates for any of the task 2 stuff. So for example, my test that contains duplicates, this is the file. I really use those same 3 songs, don't I? This is the file. We have multiple ratings for each song. And we're going to have multiple songs in that, or the same song multiple times in the list. So when the method where it says, I struggled with how to word it, and the method name came out way too long anyway, but read file without duplicates or whatever. What that means is there may be duplicates in the file, but you don't have to care. You don't have to think about the duplicates for this method. We'll fix the duplicates in task 3. For this method, you don't have to think about the duplicates. Just every time you read a line from the file, create a new song. So, bless you. So every single song that you read, every single line in the file, you read this line, you create a brand new song with it, and every song should contain exactly one rating, one song rating. So every list we expect to have one song rating, and that song rating will be from that line of the file. So you will have duplicate songs. Task 3, you're going to convert this list of songs into a map of YouTube ID to songs, and that's where you're going to handle the duplicates, but not till task 3. This last semester, all of task 2 and that part of task 3 was all one task, and I'm just like, read the file, handle duplicates, and do all the things, and it was a disaster. It was by far the hardest objective in the semester. So I split that into 3 separate methods this time to walk you through it a little easier. Hopefully that works. We'll see when we get to task 3. I'm hoping that won't be so painful going through it this way. This is where I think I did what I was supposed to do. Oh man, I have to be careful here. It did. It expanded them all on me. I collapsed these to make sure. File name to list of lines. This code I give you, that's part of the handout. Read user ratings from file. I surprisingly can show this one, and this is what I want to show. The next one I can't. All right, so when you write your methods, read user ratings from file. This is expected to be a recursive method, though I am hearing that some students did it without recursion, which I don't know how to force recursion. It's so hard. But anyway, you're expected to use recursion for this. But we have a file that's going. Do I have something messed up on here? Nope. Sometimes I have comments in my code that I'm just hoping there's not one of those. Right? Nothing. What? Me? I am scared. So I messed this up today, like this morning in 3.12. I accidentally splashed solutions on the projector. So I'm really scared because this is my solution code for the homework. I'm like, I don't want to do that again. So we're going to call, which I think I did just now, but just partially. But so the problem is this method, it's expected to be a recursive method. You would supposedly need some variables to be able to get this done without using recursion. So we want to use recursion and call this method itself. The problem we have is this method takes a file name as a parameter. So if this method is recursive and it's calling itself, we're calling it with another file, and that doesn't quite make sense. We would have to parse a line of the file, write all the remaining lines to a new file, call the same method with that new file name that we created. That's not the way we want to do things. So what we want is a recursive method with a different parameter list than the one that we have to write for the homework. So how do we do that? Well, we're just going to write the method with whatever parameters we want. So I want a method that's going to have a map with my answer in it, the partial answer, which is going to be like my accumulator, and then a list of strings, which is going to be the lines that I still need to process. So for my money, that's the way I want to set this up. You can set it up with different parameters. You don't really need this accumulator as a parameter. You could have it just as the return value, however you want to set it up. But setting up recursion on a file name doesn't really make sense. So choose whatever parameters you want. Write a method that takes those parameters, and then just call that method. So now the method that you're expected to write is going to do, one, call that file name to list of lines. That's provided for you. I gave that in the repo just so we don't have to worry about opening files. I just don't want that question in office hours, like how do I open a file when I want to be talking about recursion. So open the file, get the file as a list of strings where every string in that list is a line in the file, and then call your helper method. Call the method with the parameters that you want for your recursion, and call it with whatever initial values you want. So my initial accumulator for my map that's going to store all of the results of me after I parse the lines of the file, I'm going to initialize that to an empty map, and then each time I go one step down the recursion, I'm going to add something to that map and then make a recursive call with that extra line processed in that map. I'm just going to get away from my solutions here. All right, any questions on this? That's all I want to say about the project, so this is your time to try to pry for hints or anything if any of that didn't make sense, or if there's a particular part where a lot of you are stuck on the homework. Now's the time to get you past those issues. Was the syntax for creating a random list of doubles for AO? I use yield for that. I would iterate over a range for I in 0 to however many doubles you want, and then yield that, and then in the body of the loop just say math.random. And then if you want to scale or shift that range, so math.random is going to give you a value from 0 to 1. If you want a value from negative 100 to 100, multiply that by 200 and then subtract 100 to shift that range into whatever you want it to be. Don't just stick with the 0 to 1 because that's usually not what you exactly want. So shift and scale that range to what you want, and then yield them into a list of doubles. But what you actually want is a list of doubles, so just yield it again. You can have a yield within a yield. It's perfectly fine. Or use oh, that wouldn't really work. Or use map. Use the range and then and then map to the doubles. I think that would be a little tougher to set up though. But a yield within a yield, no harm in that. Don't even know what to do for this AO. Write a genetic algorithm. If you have a specific question, I'll be happy to help you out. But I mean, we haven't even covered task 3 content, so being lost on the application objective isn't surprising yet. We haven't even covered all the content for this homework. But if you do have a specific question, I'd be happy to help. But it is a genetic algorithm. The word among the TAs, I doubt this one a little bit, or at least some of the TAs, is that this AO is easier than the previous AO. Yeah? That's what they say. I don't know. But they do say, because I give you the outline of the algorithm, though, that there's a lot more guidance. On homework 2, it's like, I don't give you any guidance. No, well, I'm also soft on the grading for this AO, for what it's worth. I have 4 tests, and I have my grading logic checked to see if you pass 2 of them. All you need to do is pass 2 of them, and then it'll be like, I guess I'll give it to you. And AutoGrader will give you some passive-aggressive message that says, I'll give you credit, but I'm not happy about it. So you only need to get 2 of those tests, which makes it a little easier as well. Dot length equals 0 and dot length less than 1. Is there a difference between those? I mean, I guess not. Yeah, what if the length is 0.9? I don't know if dot length can ever return a negative value. Like some methods that return an integer like that, if there's an error, will return -1. I don't think dot length does that, though, for any of the data structures we're using. So, in my trying to think of where that even came from. Unless you're just joking. But I do dot length less than 2 in the in my merge sort algorithm, so it covers empty list and a list of length 1. But I don't think I ever do a less than 1. I don't know. I just don't know where that's coming from. All right. Any other questions about the homework? How many Piazza and office hour questions? I thought thought more of you would take this opportunity.
Are we allowed to know what is returned by read ratings helper? Because that's the only thing off screen right now.
Oh, it's map of string to int.
Okay.
So this returns a map of string to int, and after all the recursion returns, that's going to be the final answer. So whatever this returns, that's what I'm returning from the top level method. So that's just after all the recursion, that's the answer, the map of YouTube ID to rating. And then I do the same setup. I'm not going to, I might as well show it on screen. But I do the same setup for the next method too. I did have this question once, so just in case anybody else is having just the same exact setup, an empty list instead of an empty map this time, but the same idea. You don't have to use this accumulator. Again, you don't need to use the accumulator. I'm using that so I can do something called tail recursion, which is probably something I'll mention next week. I'll mention it very briefly right now, I guess. Tail recursion is when the recursive call is the last thing that the method does. And when you have it set up like that, it's called tail recursion. There's nothing left to do after the recursive call. So what the compiler can do is not add more stack frames for each recursive call, which saves memory. It's more efficient. It's more optimal and everything. It's just a nice thing to do. So I'm only doing the accumulator to be able to use tail recursion. Actually, I might talk about it today during the live demo, the live coding. Which, if there are no questions right now. Bless you. How much do I want to talk about testing? How much do y'all want to hear about testing? I want to talk about the method instead. I think I just talked about testing enough. So here are the tests.
That's true. The right way for
Histogram. Oh, they don't have histogram yet. Def. All right. So what we want to do,
That's why I do control S.
histogram, test histogram. Come on. Close other tabs, histogram, collapse this. Okay. So what we want to do is write a method named histogram that's going to take a list of integers and return a map of int to int, which is going to be the histogram of the list. So how often does each integer appear in the input list? And I want to do this with recursion, of course. So taking a list and returning a map, this is more of a task 3 flavor, but doing recursion with data structures, that's what we want to focus on today. How are we going to do recursion with these data structures? So just to make sure we're all in agreement on what the method should do, if I give it a list with 2 1s, 2 2s, a 3, and a 4, I should get a map mapping 1 to 2 because there are 2 1s, 2 to 2 because there are 2 2s, 3 to 1 because there's 1 3, and 4 to 1 because there's 1 4. And then we can handle certain edge cases like empty list should just return an empty map. A list with just one element should return that element mapped to 1. That should still work fine. We're going to generate a whole histogram just on one value. Negative values that are the same as their positive values, those need to be handled separately. 0 should work fine. Again, a list with one element. Again, negative numbers, I got some repetitive testing in here. 1 value showing up a whole bunch of times, 6 times for 3. All the values only appear once. Just a bunch of random testing. We had our edge cases. We had a whole bunch of regular test cases, and just thinking about everything that could possibly go wrong in a method like this. Whenever you have integers, we're worried about negative integers, negative values, making sure we handle those. Empty data structures always is a very key test case, things like that. So we have all this testing. Won't bother writing them all live. We'll just steal these. And then we want to write our histogram method to be able to get the right thing. These are maps and they're integers, so again, we can use equal equal on this one, no harm there. And let's write this thing to be able to compute this. So we're taking a list of int. I haven't done live coding in a while. This feels strange. Map of int to int. And we're going to return some map. So let's write this histogram. We're not going to use any vars. We're certainly going to use recursion. This input is kind of what I want, so I don't have to write a helper method yet. As long as we have time, I can write a helper method for this and talk about tail recursion at least a little bit. You won't be asked about tail recursion on your interviews, but it's useful enough, and since we're talking about recursion, let's at least get it out there. So we want to write this. Now, what I would normally do is initialize an empty map, iterate over the values of the list, and then for each value in the list, I'm going to check if that value exists in the map. If it does, add 1 to its value. If it doesn't exist in the map, add a new key value pair with that value mapping to 1. That's what I would normally do, except that would require var and then my map. Not allowed. We can't have a var. So I'm going to pull out some recursion and do some recursion for this. So I'm going to go through my steps for successful recursion. Let's go through each one. First one, base case, input, trivial, input-output behavior. If data is empty, I'm going to return an empty map. We had that right in our test cases, and this is one of the advantages of writing your test cases first. You're thinking through all of the different inputs, all of the strange inputs, especially the edge cases, and thinking what should happen. So now it's easy to pick out my base case. If data is the empty list, I'm going to return the empty map. We know that because we were at our test cases and thought about it during our test cases. What should empty list return? Empty map. And then we can get that out of the way there. If we don't hit that base case, we want to make a recursive call, hit our recursive step, and that's where our other three ingredients are going to be. So we're writing our recursive step. We have one very strong assumption that we can use, and that's that our recursive calls are going to return the correct value as long as we're getting closer to the base case. So I'm going to make a call that's closer to the base case, and whenever I write this, I want to think, what's the smallest step I can do to get closer to the base case? And then that's going to be my recursive call. In this case, as is usually the case when we're dealing with data structures, is I want to process one single element from the data structure, and that's it. So my recursive call is going to be all the elements of my data except one. Drop one is going to return a new list with all of the elements of that list except the first one. So I can call drop one, get rid of one element. This actually does the same thing as next, I believe. Last. We'll get there. Tail. Does the same thing as tail, which I was going to say I expect tail to just call drop one. So drop one, that's going to make a recursive call on everything except the first element of this list. And that's going to be my starting point. When I'm thinking through a recursive method, this is usually where I start. Okay, I can make a recursive call. Let me make a recursive call that's the smallest step possible closer to the base case. Data can't have a negative length. So to get closer to a length of 0, I'm going to remove one element from it. And I'm going to assume that this histogram partial histogram of type map of int to int is correct. So I'm assuming that partial histogram is going to be correct, and my job is to process that one element that I removed. So I only need to process the first element of this list. To do that, I need to do one check. If partial histogram, there's one big check I have to do and see if this contains data.head. So I'm going to do two different things. If the map, the partial histogram of all of the other elements processed contains the value I'm looking at, then I want to do one thing. If it doesn't contain the value I'm looking at, I want to do another thing. So if it doesn't contain it, that's the easier step. I'm going to return partial histogram and add a new key value pair of data.head, the first element, the only element I need to process, and map that to 1. It's the first time I've seen it. Therefore, I've seen this thing exactly one time. If I've already seen it, I'm going to return partial histogram plus, now I can't just pick a number or whatever. Now I have to go to partial histogram of data.head. So I want to know how many times have I seen this thing before. Sorry, let me get this part first. Data.head, whatever value this is that we're looking at, I want to map this to a value. I'm going to ask the histogram, hey, how many times have we seen this thing before? And then add 1 to it. However many times we've seen this before, we've seen it one more time now. It thinks that that's part of the other expression, so we're going to slap some more parentheses on there to make sure that the addition happens before the mapping, is what that error was. And so we're just going to add 1. Pull it from the map, say, hey, how many times have we seen this? Add 1 to that, and then replace that key value pair with the new key value pair. So a key value pair, a map in this case, can only have each key exactly once. So if we add this new key value pair with a key that's already in the map, it's going to replace the old value in the map with the updated one, with the value that has 1 added to it, which is exactly what we want. And this is the last thing that happens in this method, is this conditional. So I'm taking advantage of the fact that the last expression is going to be the new map with the new key value pair added, which is processing this one single element. So we've accomplished our task. We got our base case trivial input output. We made a recursive call that's one step closer to the base case. So assume that's true. Make sure it gets closer to the base case. And then the fourth ingredient, we built all of our logic around that. If this does give me the correct answer for all of the elements except this one, the first one, then my logic is going to process that first element, and then I'm done. And then return the partial solution plus processing that one element that isn't included in the partial solution. Let's run our test to make sure that works. And it does. And usually something I like to do when I'm writing tests is intentionally break my code and make sure the test fails. I like to make sure the tests are actually testing something. If you mess up your test cases, it might just pass everything by default. So I like to watch my tests fail, and we can see where it failed. We got this map, which did not equal this map. So our map contains all of the right stuff, except it also has that key value pair 7 and 9. So we're feeling good that this is actually properly testing our code, doing its job, and that our code is actually correct, because when we get rid of this, we pass those tests. Yeah, them green check marks feel good. They feel good. I only have a minute, so I'm not going to be able to do the I won't be able to do the tail recursion one. Any questions on this? Yeah, once you submit the question, have a great weekend. Hopefully I'll see you all at UB Hacking tomorrow. Woo! If not, I'll see you Monday.